In section 10.5, we're going to continue working with area and use trigonometry to find areas. So we want to find the area of a regular nonagon, that's 9 sides, with 10 centimeter sides. So each side is 10 centimeters. This is a nonagon, so each interior angle is 360 divided by 9, which is 40 degrees. So subtracting that from 180 leaves me 140, and therefore these two angles here are 70 degrees each. So those are the dimensions and what we have. So let's pull out here one of our triangles, a base of 10, an apothem that we don't know how long it is, but I do know that this angle here is 20 degrees, and the angle down here is 70 degrees. Now in the last section, all of our triangles were special triangles, 30, 60, 90. But in this case, we need to find the apothem using either the 20 degree or 70 degree angle. So I'm going to say that the tangent of 70 degrees is the opposite, which is the apothem, over the adjacent, which is half of this, or 5. Therefore, the apothem is 5 times the tangent of 70 degrees. Going back to my area formula, area is 1/2 of the apothem times the perimeter. So 1/2, the apothem is 5 tan 70. The perimeter is 10 times 9, or 90. If I put that all into the calculator, I get 618.1824. So that's the area of a regular nonagon. So the same thing we've been doing as in 10.4, but now we need to use trig functions and our calculator because these are not going to be special triangles. All right, find the area of a stop sign with a radius of 16.2. So there's my stop sign, and if I put my diagonals in, drawn very well, sorry about that. This is 8 sides, and the radius here is 16.2. So again, we got to find some angle measures. 360 divided by 8 is 45. If I subtract 45 from 180 to get my two angles here at the bottom, those are 67.5 for each one. Again, I like to draw the triangle off to the side so that I know what I'm looking at. The radius, which is one of these sides, is 16.2. Half of 45 is 22.5 up here, 67.5 down here. I need to find both the apothem and the base. So let's start with the sine of 67.5, because sine is opposite over hypotenuse. So that's the apothem over 16.2. So 16.2 times the sine of 67.5 will be the area or the length of the apothem. I went ahead and worked this out. I got 14.96684. So I've got the apothem. Now I need to find the base. So I'm going to find this little half of the base. And the base is going to be, what did I use for that? I'm not sure. Oh, I think I did. I didn't write on my paper. I think I did Pythagorean there. But I got the base to be 12.3989, and that was the entire base. So using my area formula, I found the perimeter to be the base times 9. So using 1/2 the apothem times the perimeter, 12.3989 times my, 8 sides. And my total area was 742.2919. So I'm sorry that I didn't write down my calculation for that, but there's a couple ways to do it. If that's my base, I could do the cosine of 67.5 equals adjacent, which is half of the base over the hypotenuse. And so I could find half of my base using this formula. All right, so the idea again is using a calculator to find given missing pieces so that we can find the area. All right, we're also going to use trig to find the area of a triangle. Now normally, to find the area, don't write this down yet, to find the area of a triangle I need 1/2 the base times the height. Well, I don't know the height. So let's take a look. If I am given side, angle, side, so if I'm given side B, angle C, and side A, if I take the sine of angle C, that's going to be, in this little triangle over here on the left, opposite over hypotenuse, H over B. So I know that the height is always sine C times B, multiply both sides by B. I take my regular area of a triangle, 1/2 the base times the height. The area is 1/2. The base in this case is side A. The height, we just said, was B sine C. So that's how we came up with this formula given angle C. And basically what we're going to be using is 1/2 of the sine of the angle times its two adjacent sides. That's my side, angle, side again. So the area of a triangle using trigonometry is 1/2 the side length times the side length times the sine of the included angle. So let's try one of these. Oops, go back a minute. All right, so if I have a triangle, oh, come on, that looks like this, and I give you 54 degrees here, 10 on this side and 16 on this side. So the area is 1/2 10 times 16 times the sine of 54 degrees. Put all that in your calculator, you will get 44.735. Okay, so a little bit of trig, finding our angles for the regular polygons, and then a new formula to find the area of a triangle if you don't know a perpendicular height, but you have an angle and two adjacent sides.